Okay, so resuming, we found the displacement for that interval, the 0 to 1 second interval, to be 2.5 meters. Now we can do the same thing in each of these other intervals. Let me do one more for you, and then you can go ahead and try them on your own. So in the next interval here, from the 1 to 2 second interval, the average velocity was 7.5 meters per second. And we want to know what is the displacement in that 1 to 2 second interval. And that 1 to 2 second interval had a time span of 1 second, and therefore the the displacement is 7.5 meters. That is 1 times 7.5 gives 7.5. Now, you should take some time to fill out the rest of this chart for that interval displacement. All right, so hopefully as you calculated these displacements for each interval, you came up with numbers like these, following that same process. What I want to do now is see what happens to the total displacement, that is the displacement since time 0. So we'll call that total. All right, so at time 0, it was at 0. But then after 1 second of travel, it had had a total displacement of 2.5 meters. After 2 seconds of travel, it had gone 2.5 in the first second. By the end of the second, it had gone an additional 7.5. 2.5 and 7.5 is 10.5. Then at the end of 3 seconds, it had gone 10.5 originally, plus an additional 12.5 for a total of 23. And then an additional 12.5 is 37.5. And then at 5 seconds, an additional 7.5 or 44. Excuse me, that's 45. And then in the next instant of time, it went by the end of the 6th second, it went 45 up to the 5th second, and then 2.5 is 47.5. And then after the 7th second, 47.5, and then minus 2.5 is 45, and then 37.5 by the 8th second. So let me write the times over here so that's a little clearer. This is at time 0, after 1 second, after 2, after 3, after 4 seconds, after 5 seconds, after 6 seconds, after 7 seconds, after 8 seconds. And so you can see from this that in fact, as we stated before over here, the total displacement keeps getting larger and larger and larger until the 6th second, where it begins to get smaller. It's right in here that the object actually turns around. Not back earlier when its acceleration switched direction, but here when its velocity switches direction. Then it begins to turn around. Now I want to go back and tackle another common misconception. It is sometimes assumed by students that an object, if it started at 0 and ended going 5 meters per second, and it traveled for 1 second, that it should go 5 meters. But the point I want to make is that it wasn't traveling 5 meters per second that entire time. It was only right here at the end of that first second that it was going 5 meters per second. And that's why to find how far it went in that interval, you need the average velocity, because it was traveling very slow to begin with and only fast right at the end. So it's the average that you're going to care about to find out how far it went.